An equivalent definition of the Mandelbrot set is that we consider all complex values, capital C, such that the absolute value of set n does not converge to infinity for all n, when n goes to infinity. And this definition is equivalent. It's namely possible to show that if this condition is not met, that we can find some n such that absolute value of set is larger than 2, then the absolute value of set n will go to infinity for this particular choice of C when n goes to infinity. Let's give an illustration of the Mandelbrot set. This illustration is computed by the program fructint, which is possible to download from internet. Just search on this term. Here we see some arrow, and in this arrow we see the coordinate in the complex plane. So it's, you see the x value and y value is very close to 0. So we are in the origin in some sense. So along this line we have the x-axis, and the y-axis is up here. So all these black points are now the Mandelbrot set. In this set, when the program is trying to iterate for a particular value of C, iterate by using the recursive formula, it will, after several hundred of thousand iteration, observe that the absolute value of set n is less than 2, and then it decides to make this point a part of the Mandelbrot set. In the area outside the black black points, what is the color here indicating? Well, the color is indicating that, for example, in the blue area, we just need a couple of iterations before the set n, in the absolute value of set n, is larger than 2. Here we need perhaps 10 iterations. Here we need 100. Here, for example, 500, and so on. So very close to the Mandelbrot set, we need several thousand iterations in order to check if the point is within the Mandelbrot set or not. Let me just show you this program can be used to focus on some points. We can zoom into some area in the Mandelbrot set and discover new parts of the Mandelbrot set which never have been seen before. Like we are seeing here. Here is in a very small part of the Mandelbrot set.